Good afternoon. Today I will be presenting my project progress presentation for AERO4842, where I'll be focusing on a multi-sensor environment package. Our mission scenario is a landed Europa exploration mission where it is assumed that the probe has drilled through the moon's icy shell and deployed on the subsurface of the ocean. Europa is one of the most promising sites for extraterrestrial habitability, as the ocean may contain what is needed to support life. To assess that, we must determine the local environment, as the temperature reveals energy availability, depth and pressure defines the ice-ocean interaction, and pH and salinity show crucial chemical balance for sustaining life. My project simulates this investigation on Earth through a multi-sensor environment package capable of collecting temperature levels, salinity, and pH all in real time. The main apparatus contains a breadboard kit, DS18B20 water temperature sensor, the LLC4965 water level sensor, and Arduino Uno, as well as other connecting wires. I selected the temperature sensor because it provides high precision digital readings with an error of about half a degree Celsius. The LLC water level sensor was chosen for its analog simple linear response, allowing me to simulate immersion depth and detect fluid contact reliably. Together they form a scalable base for future integration of the two other sensors, and that will come in the next steps of the project. Lastly, both sensors were coded using the Arduino I to obtain the results. My approach uses an Arduino-based simulation to integrate and validate both sensors. The code continuously reads temperature and water level data and outputs it through the serial monitor for calibration and consistency. By running both sensors simultaneously, I can verify that the system collects synchronized environmental data, mirroring how a Europa submersible system would record conditions beneath the ice in real time. Next, I'll go through a live example.
So here in this live video, you have the Arduino, the breadboard, and the two sensors. Both sensors are originally out of the water, so obviously this should have no readings, and the temperature should be just ambient air. And here is ice water to try to simulate, a colder climate. So now I will start the simulation, and then I will put the level sensor in the water so we can view what the differences are, as well as the temperature sensor, and then we will see the differences.
As seen by the results here, when the sensors are exposed to the ambient air, the temperature is 18.56 degrees Celsius and the level is 10%. But as the sensors are both submerged at about 2 seconds, you can see that the level immediately jumps up to about 57%, and the temperature slowly declines as observed after 31 seconds of being in the ice water. The next step is to incorporate the pH and salinity sensor to complete the multi-parameter package. Then I will also create a submergible frame for the apparatus to lay on the water, with each sensor taking its readings. I will then graph each result to demonstrate its ability to get data and relay said information. Ultimately, this work aims to create a reliable, low-power sensing platform that can support habitability analysis for Europa and other icy moon missions in future exploration.